So I wanted to do this question with you guys because I thought it was an interesting question. It has you work backwards, and you'll see what I mean when I say that. So in a 7.6 gram sample of dinitrogen, so 2 nitrogens, tetroxide, so 4 oxygens, what mass of oxygen is present? So they're asking me about the mass. And you're like here like, all right, I got this. Nitrogen, I know from the periodic table, has a mass of 4.007, and I have 2 of those. And then oxygen has a mass of 15.999, and I have 4 of those. So now I'm just gonna take my calculator and multiply, because this ain't that hard. 14.007 times 2, which is equal to 28.014, and 15.999 times 4, which is equal to 63.996. And then you're like, yeah, I'm gonna add these two up to find the whole molar mass of this thing. So plus 28.04, and that is 92.01 grams per mole. And you're like, oh yeah, Ms. Rodriguez ain't got nothing on me. But then you're like, wait, I have a total of 92.01 grams per mole, but they only have 7.6 grams. So how am I supposed to be like, yeah, I have 28 grams of, or oxygen. I have 63 grams of oxygen, but I actually only have a total of 7.6 grams of this sample. So this is where you work backwards. So the formula of mass percent, again, is whatever you're trying to find the percentage of over the total mass times 100. So because we're trying to find the percent of oxygen, I'm going to use my oxygen mass, 63.996, divided by the total mass, which is 92.01 times 100. If I get on my handy dandy calculator, 63.996 divided by 92.01 times 100. So I know that the percentage of oxygen in my compound is about 69.6%. So now I can use this that I know to figure out the grams of this sample that have oxygen. So again, go back to my formula. Remember my formula. I can plug in numbers, right? So if my mass percent of oxygen, right, is 69.6 is equal to the mass of oxygen that I'm trying to find in this sample over the total mass of the whole thing. So the total mass of all of my sample, I know that this is the mass percent of oxygen. I found that by doing like this thing, right? So 69.6%. And my X, the one that I'm trying to find, is the mass of oxygen within this sample, right? So then obviously times 100. Okay, so let's first get rid of this times 100 that's bothering me. So I'm going to divide by 100 on both sides to get rid of that 100. So 69.6, here you go, divided by 100 is equal to 0.696 is equal to X over 7.6, and I got rid of that. Great, so now I can finally solve this equation because I'm going to do the little butterfly thing that you've seen me do before. So I'm going to multiply these two together, and I'm going to multiply these two together. There's nothing over here, so I can say that this is over 1. So when I multiply X times 1, I have X is equal to, and then I have 0.696 times 7.6, and that is equal to 5.29 approximately, and we are talking about grams. So that is my answer. I have 5.29 grams of oxygen within a 7.26 gram sample of this compound. Again, what I did is I kind of worked backwards. I found the percentage that I knew was true just based on this compound, right? The molar mass of this whole thing, and then I found the percentage that oxygen takes up, and the percentage will always remain true no matter the weight. So then I could plug in the percentage into my mass percent with a different total mass and then just solve for x, and that's all I did.